Welcome to the 9.8 video about solving systems of quadratic equations. So this is similar to what we did a couple days ago, but now elimination is not going to work. So we're going to have to be using substitution, which makes these problems a little more difficult. But again, you are finding where these two conic shapes will intersect. So first thing is, let's figure out what shapes we're working with. So looking at the first equation, we have 5x squared plus 16y squared plus 10x minus 64y equals 75. Now, we have learned a lot of ways to look at what shape we're working with. If you're still unsure, you can look on Schoology under Day 7 Homework Summary, and that will really walk you through what you're looking for in an equation besides actually graphing it, completing the square, and finding what shape. So looking at it, the two things that jump out to me is there's two square terms, so already parabolas out of the situation, and then you see there's a 5 as a coefficient and a 16 as a coefficient. They're both positive, so that means hyperbola is out of the situation, and because they're not the same, I know it's going to be an ellipse. So my first shape is an ellipse. Okay, then my next shape, don't be confused by it. Notice there's no square term. There's not even one square term. So I can't be a circle, can't be ellipse, can't be hyperbola, because those both have two square terms. It's not a parabola because there's not even one square term. So it is okay. You are just a line, right? Y equals mx plus b. So I'm finding where this line crosses the ellipse. So at least we have a general idea of what we are doing. Now, sadly, like I mentioned before, it's not going to work to do elimination because your square terms are going to be stuck in your problem. So now we bring in substitution. Well, what I'm going to do is, on my line equation, I'm going to solve for y, and then I'm going to plug it in. So if I solve for y, negative 4y would equal negative 5x minus 1. So y really equals 5 over 4x plus 1 over 4. So very gross, I know. But we're going to take it and actually substitute it in to that y as well as to the y squared. Okay, so very simple steps, but now it gets a little bit messy. So let's get started. We will have 5x squared plus 16. Now in parentheses, we have this. And that's all being squared. We have our plus 10x. And then we have our minus 64 times this. And it's all going to equal 75. So first step, like always, is going to actually be to FOIL this 5 divided by 4x plus 1/4, as well as at the same time, I'm going to distribute this negative sign. So this will be my first step. So I get 5x squared plus 16. When you FOIL that out, you'll get 25 over 16x squared. And it's actually, I'm going to rewrite this a little clearer. So you see the x squared is not in the denominator. It's just next to it. So I want to make that clear. Plus 5 over 8x plus 1 over 16. A little messy. Then you have everything else we were working with. The 10x. When you do your distributing, you should get negative 80x. Then you will get negative 16 equals 75. So that's not too bad. Now let's do our distributing into your FOIL term. Should get plus 25x squared plus 10x plus 1. That actually is very nice. Okay, let's combine some like terms. So I have 5x squared and 25x squared. Okay, so that's 30x squared. I have minus 60x minus 15. I'm going to subtract over that 75, have it equal 0. So 30x squared minus 60x minus 90. Looks like a nice GCF can come out. Oh, this is very nice then. We're going to factor. That's x plus 1. Zero product property, so I have x equaling 3 and x equaling negative 1. Okay, so kind of messy at the beginning, but then it actually turns out pretty nice. Now think back to when we did these problems a couple days ago. You need to now check when x is 3 and when x is negative 1, what the corresponding y value will be. I'm going to do that over here. So when x equals 3, that'll be my first one. I'm going to plug into the bottom equation. I just think that's easier. So 5 times 3 minus 4y equals negative 1. I'm getting y to be 4. When x is negative 1, you do the same thing. And I'm getting y to be 1. So my 2 points where these two shapes cross is going to be 3, 4. And the last point will be negative 1, 1. So that is the algebraic solution of where this ellipse and line will cross. Okay, let's try another one. Again, first idea is figure out what shapes are you working with. Well, I'm looking at the first one. I see there's 2 squared terms, so I know a line and parabola are out. I notice that they do not have the same coefficient in front, so not going to be a circle. I do notice that one term is negative. So when one term is negative, I know hyperbola. And again, if you're like, wow, how do you know that? Please look at the Day 7 homework summary that is posted on Schoology to help you with these shapes. Now the last one, xy equals negative 24. Now I could see some of you thinking, oh, it's a line. No square term, I'm good to go. But realize that this is one of those special cases that you'll see in the Day 7 homework summary. Because there's an xy term, look through all the situation, this is actually a hyperbola as well. Okay, so I'm trying to find where there's 2 hyperbolas where will cross. Sadly, elimination is out of the case, so substitution is where I need to work. I'm going to choose to get the y in the bottom equation by itself. So xy equals negative 24. I'm going to just solve for x. So get rid of the y. Again, it doesn't matter what variable you solve for. If you want a challenge, go forth, find what y is by itself. So I'm going to take that, substitute it in here, and now let's get to work. So I know this is really negative 24 over y squared minus 5y squared equals negative 44. Really 576 over y squared. Again, I'm showing a lot of steps. You don't have to show all these if you don't want. Now there is the denominator of y squared. I want to get rid of that. So I'm going to actually multiply everything by y squared just because it's in the denominator. It's an equation. you want to get rid of the denominator. So you get 576 minus 5y to the fourth is going to equal negative 44 y squared. Similar to the problem we just did, let's get it to equal 0. So 0 is going to equal, I always put my terms from highest power to lowest power. So it would be 5y squared, 5y to the fourth, I'm moving everything to the right, minus 44y squared minus 576. Okay, so that should be pretty good so far. At this step, you now have some options. You can complete this, you can factor this by splitting the middle. If you can visually see it, that works. You could do U substitution if you want. You could use quadratic formula, I guess, if you really want to. But in the end, and I'm going to jump some steps, so this is stuff that you should fill in, be able to do. In the end, I am getting, once I split the middle, once I split the middle, I get y squared minus 16, and my other term to be 5y squared plus 36. So please, if you have questions on that middle step, let us know. But it's just a U substitution if you want, or split the middle. Well, now in this case, I can set them equal to 0 because I know that they're going to be a zero product property. I'm going to get 0 equals y squared minus 16. So 16 equals y squared, square root. You put the square root in, so make sure you remember it's plus or minus 4. Here, it would be equal to 0. Now notice when I solve, I'll get y squared would equal negative 36 over 5, and you cannot take a square root of a negative. These are not going to be imaginary solutions. This is really where do these two hyperbolas cross. So this one, just not possible. It's not going to cross in this area because you cannot take a square root of a negative. So really, my only point will be y being plus or minus 4. Well, let's figure out what the corresponding x values will be. So if y equals 4, going to my equation, that would be x times 4 equals negative 24. I'm getting x to be negative 6. If y equals negative 4, that's my other option. You get x times negative 4 equals negative 24. So in this case, x would be 6. So the 2 points where this crosses would be negative 4, comma, positive 6, and 4, comma, negative 6. Okay, so again, a little bit of work to do algebra-wise. If you have questions on this step right here, please make sure you know it's split the middle. And you can get some help there. Now, this is part 1 of the video. So once you are done with this part, please follow the assignments that's due. I'm going to now begin part 2 of the video, which is writing equations of hyperbolas and parabolas. Okay, welcome to part 2 of the video. We're now going to write equations of the hyperbolas with the given information. A couple things to remember. The transverse axis is based on whichever is positive. The vertices and foci lie on that transverse axis. The length of the transverse axis is the distance from vertex to vertex. The conjugate axis is just the other one. Okay, let's get started here. As always, I like to draw the picture. I'm actually zoom in a tad. Sorry, it's going to be a little weird, but let's draw a picture. So, vertices of 2, 6 and 2, 12. I'm going to go like this. I'm going to go down because we have a lot to cover. So 1, 2, 1, 2, 3, 4, 5, 6. And 12, 1, 2, 3, 4, 5, 6. Those are my two vertices. The length of the conjugate axis is 16. So that's going actually horizontal this time because the conjugate is the other axis. Well, let's find my center. That's always important. So what's in between these two? I'm getting 2, 9. So 6, 7, 8, 9. Right here. I'm going to write that out. Oops. Center. 2, 9. Again, it's just what's right in between my vertices. The length of the conjugate is 16. So that means I'm going to go 16 to the right and left. Which means, 16 is the total. So 8 to the right, 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. Again, this is a basic sketch. And here, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Again, this is a hyperbola, so don't be nervous that the longer axis is not the transverse axis. And now I can start working some of this information. So I know here to here is my Rx, which is 8. I know from here to here is my Ry, and Ry is 3. So I can now write my equation. I know my center, so x minus 2 squared. I know this one's going to be y, oops, that should be a y. Y minus 9 squared, I know it equals 1. I know my Ry is 3, so 3 squared is 9. I know my Rx is 8. 8 squared is 64. Now I have to worry about the sign. Now this is a hyperbola. Those are my vertices, so I know it's looking like this. Okay, basic sketch right there. Well, that means it opens in the y direction. Since it opens to the y is positive and the exit is negative. So please watch out for that last step with hyperbolas. One of the terms have to be negative depending on which way your graph opens. Again, very basic sketches. If you don't need them, that's fine. I just think it's helpful to find the equation. Okay, next one. The foci is -4, -4, 6, -4. Length of the transverse is 8. Okay, so I'm going to draw that. I'll go kind of like this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So those are my foci. And then length of the transverse is 8. Well, length of the transverse is 8. Transverse is from the center to the vertices. Okay, that's important to know. So really, from the vertices, from the center, is 4 to the right, 4 to the left. First, let's always find our center. That's important. Well, because -4 and 6, that's 10, so 5 away would be 1, -4. So here's my center. Center is 1, -4. And I know my transverse is 8, so that means I go 4 to the right, 4 to the left. Right here are my vertices. Right, this is where my shape will begin. Well, that tells me from here to here, my Rx is 4. Then I also know from here to here, that's my focus length. So my focus length is 5. Well, I'm going to start building my equation and see kind of what I'm missing. I know my center, x minus 1 squared. y plus 4 squared. I know I'm going to equal 1. I know that I'm opening in the x direction, so I know the y term is going to be negative. I know my rx is 4, so rx squared would be 16. But I don't know my ry. We're now going to use the equation, similar to what we did a couple days ago, but now with hyperbolas, with foci. So we know the equation is f squared equals rx squared plus ry squared. We're in hyperbolas, so hyperbolas you add. Same idea, but we actually already know the focal distance. From the center to the focus is 5, so 5 squared is 25. We know rx is 4, rx squared is 16. Now we're going to solve for ry squared. Again, we don't even need to find ry. All we really want is ry squared. So, doing some math, I'm getting 9 equals ry squared. And that's all I want. So I'm going to put that underneath my y. And there's my equation of my hyperbola. I know it's a hyperbola because one of the terms is negative. Okay, last one is now a parabola. Then we'll be almost done. So the equation of the parabolas with the given equation, know that parabolas just have one squared term, and this has that 4p action that we're working with. So let's write what we know. The vertex is 1, 4. Directrix is x equals 6. So here's my picture. 1, 1, 2, 3, 4. Directrix x equals 6. So 1, 2, 3, 4, 5, 6. Remember the directrix is that dashed line perpendicular to the axes of symmetry in your parabola. Okay, lots of things we're working with. I can see that this distance from the vertex to the directrix, is 5, which means I have to go 5 units from the vertex to get your focus. So 1, 2, 3, 4, 5. In this direction, there is the focus, which shows me that I'm going to be opening to the left because I need to have my focus in the curve. Well, this gives me a lot of information to work with. I now know that I have 5 away, so that's my p-value. And now I can start looking at my equation. Okay, so vertex 1, 4, super important. Notice this is the p-value. So p equals 5, absolute value of p equals 5. Now notice it opens to the left. Everything we've talked about, if it opens to the left or down, the p-value needs to be negative. So you can really think of it as, okay, p needs to be negative 5. So 4p would really be negative 20. That's important for my equation. Again, we know this because it goes to the left or if it went down. So let's start my equation. I know it is x minus 1, and it's going to equal y minus 4 squared. So my y term is my squared term. Now I need to put that 4p into my problem. Well, the 4p goes in front of your non-squared term. So just like that, there's my equation. Okay, a lot of things happen based on this 4p right here. Okay, let's try one more. The focus is negative 3, 2, and the directrix is y equals negative 2. Let me draw my picture. So 1, 2, 3, 1, 2. This is now the focus. And here's the directrix. Well, I know it's going to have to open up because the focus is above the directrix. I need to find my vertex though, what's in the middle. Well, this total distance from here to here is 4, so I need to find my center, which would be right here. So my center is right in the middle, which is -3, 0. I know it's going to open up because we have to have my focus inside the parabola. I now can find my P length, which is from the focus to center or center to directrix. So the P is 2. I know it opens up, so my P is going to be positive. I have my P equals 2, my absolute value, right, that distance. Since it opens up, it's going to stay being 2. So 4P will equal 8. Now we can write our equation. We have our x plus 3 squared term. It's going to equal my just y, right? It could be y minus 0 or just y because it stays in place. And now I have to put my 4p value. Well, 4p right here would be 8. Now, I wrote it this time with my squared term first for no reason. You could rewrite it like this. It is the same thing, obviously. Just depends on where you want to put your squared term. Again, the x is squared, so I know that I'm going up or down. And since my p-value is positive, I know I go up. If you have any questions, feel free to ask them. Please try your homework tonight for part 2. Good luck.